Hello students, I am Dr. Noor Danish, and in this lecture I am going to speak about the dual nature of electrons, and to verify the dual nature I will be using the double slit experiment. So we know that electrons are actually material particles, but as I told earlier that they have dual nature, means the two behave as a wave, and we know the two important characteristics of waves are diffraction and interference. So the diffraction experiment was verified by the Division-German experiment, and the interference experiment of electron is verified by the double slit experiment. So first we need to have electrons, and that electrons we can have from the electron beam source. So first we take a filament which is heated, and then after the heating these filaments are emitting electrons, and those electrons are accelerated using a high tension between the filament and the anode, cylindrical anode, and these electrons come out from the slit S1 and S2. Now these two electrons will come out are in this direction. They are passed through the two slit S1 and S2, and then a photographic plate is put there. Now these two slits S1 and S2 are parallel to this SS, and thus they act as a two coherent source of the same type of photons. Now with this experiment we observe, and this experiment is carried out in a vacuum. With this experiment we observe a graphical pattern on the photographic plate of the intensity like this. So if this is the, and as we are aware that this type of pattern is possible only when it is a interference of the light which got secondary wavelet from the S1 and S2, because otherwise if it is a matter particle it will be coming at only one point, but we are seeing that an intensity at this point, like if you say this point and this point are their intensity, because they are means their maximum are at the different point as we should observe in the double slit experiment of the normal visible light. Thus what it conclude? It conclude that the matter 2 means electrons here are behaving or giving the property of the interference using this maxima. I am using this thickness of these maximas, and continue to, and the difference between the two maximas and the distance from this slit to the photographic plate. You can also calculate the wavelength of these these lights, and which are due to the electrons. So what we conclude, the same experiment using the photon was giving me the wavelength, and the same electron, so the same experiment using electrons is giving me the wavelength of that electrons. So this experiment perhaps shows me that matter 2 behaves like a wave. Thank you for listening.